It's Sci Time!
Who's ready for some science awesomeness? Welcome to It's Sci Time.
Today, we're uncovering the secrets of ionic and covalent substances.
Have you ever wondered what materials heat sinks are made of that help them manage heat effectively and prevent overheating in computers?
Why is aluminum nitride a suitable material for computer heat sinks?
Are you ready? It's Sci Time!
Compounds. In our everyday lives, we can deny the fact that we encounter different forms of compounds. So what are compounds? These are chemical substances made up of two or more elements that are chemically bound together in a fixed ratio. This just means that when two hydrogen atoms and one oxygen atom combine through what we call a covalent bond, a water molecule is formed.
There are types of compounds formed based on their bonds. We have the ionic compounds and the covalent compounds. First, ionic compounds. These are chemical compounds composed of ions held together by electrostatic forces termed ionic bonding. They are neutral overall but consist of positively charged ions called cations and negatively charged ions called anions. Examples of ionic compounds include your sodium chloride, which is commonly known as your table salt, and sodium fluoride, which is a component of toothpaste. Ionic compounds are formed between a metal element, which is your cation, and a non-metal element, which is your anion. In an ionic bonding, the metal element donates an electron to the non-metal element, achieving stability. Next, we have the covalent compounds, which are molecules formed by the covalent bonds, in which the atoms share one or more pairs of valence electrons. And these compounds are formed between two non-metal elements. Most of the non-metal elements have half or more than half of valence electrons in their respective valence shell. During covalent bonding, the two non-metal elements share electrons to achieve stability. The molecules in a covalent compound are held together by intermolecular forces, and these forces are very weak. The property of ionic and covalent substances that we are going to investigate in this video is thermal conductivity, which is the ability of a material to conduct heat. It measures how efficiently heat energy is transferred through a substance. To begin, let's review the three heat transfer mechanisms. First, conduction. It involves direct transfer of heat between particles in physical contact. Second, convection. It involves heat transfer through fluid motion. And third, radiation. It involves heat transfer through electromagnetic waves. Let's now investigate the thermal conductivity of ionic and covalent substances using a metal spoon, thermometer, sugar, salt, and hot water. Which one will conduct heat better, the sugar or the salt? If you want to try this cool experiment at home, just remember to ask a grown-up for help. They can guide you through it and make sure everything stays safe and fun. Time for the experiment.
First, record the initial temperature of both spoons. One spoon with salt, the other spoon with sugar. Next, carefully place the edge of each spoon into the hot water, avoiding full submersion. Let it sit for exactly 2 minutes. After that, remove the spoons and immediately record their temperatures.
Let's analyze our experimental findings, focusing on how ionic and covalent compounds differ in terms of thermal conductivity. What type of compound is salt? How about sugar? Salt is an ionic compound, while sugar is a covalent compound.
How did the temperature of the sugar and salt change over time? Which one increased faster? The temperature of sugar increased faster than salt. This shows sugar heats up quickly, possibly due to its molecular structure.
What type of heat transfer occurred when the spoon was placed in hot water? Conduction, because heat is transferred from the hot water through the spoon into the substance by direct contact. Why do you think there was a difference in how fast the temperature of salt and sugar changed? Because sugar is a covalent compound and has weaker intermolecular forces, it absorbs heat faster. Salt, being ionic, has stronger bands that resist temperature change. Which substance demonstrated better thermal conductivity? Explain using your observations. Salt showed better thermal conductivity because it changed temperature more slowly and consistently, which indicates it transferred heat more gradually through its structure.
How do the changes in temperature help us compare the thermal conductivity of ionic and covalent substances? The slower temperature increase in salt shows it absorbs and transfers heat gradually, indicating stronger bonding and higher thermal conductivity in solid state. Sugar's quick temperature rise may mean it's less stable and not as effective at conducting heat. Let's go back to our primary inquiry question. Why is aluminum nitride a suitable material for computer heat sinks? Aluminum nitride is suitable for computer heat sinks due to its high thermal conductivity, which enables efficient heat transfer away from the source, allowing for effective heat dissipation and temperature management in electronic devices.
Let's wrap up. Take a look at this concept map, which highlights the key links between ionic and covalent compounds and how they conduct heat.
Real-world connection ahead. Let's put your new knowledge into action and explore how ionic and covalent substances impact our everyday lives.
In Tuguegarao, Anna prepared banana pancakes using her ceramic pan. The pan's even heating ensured golden edges and fluffy centers. Unlike her old metal pan, which caused uneven cooking, the ceramic pan delivered consistent results. Breakfast was a hit, thanks to her pan's efficient heat distribution.
What can be inferred about the composition of ceramic pans and how they facilitate more even heating? Ceramic pans provide more even heating because they are typically made of materials with covalent bonds, which have lower thermal conductivity compared to metals with ionic bonds and free electrons. This lower thermal conductivity helps distribute heat more evenly, reducing hot spots and promoting consistent cooking results.
Thanks for joining us on this SciTime adventure. We'll catch you again in our next episode, packed with more exciting science discoveries.